ISTE. So I don't want to discuss more about sir's achievement and directly request Nitish sir to please start this session. And on behalf of our university and UGC-HRDC and all the participants, I welcome you, sir, for joining and sparing some time for we people. So, welcome, sir.
Thank you, sir, for your warm welcome, and good morning, BPS Women University management, all the faculty members and the bright students. And today we are just going to discuss about one of the cutting-edge technology, IoT, which actually provide that a technology penetration towards downside means everywhere, that in your household, in your business, in your offices, and soon that all we will be interface with the IoT in any way, from home to from office. So I'm just going to share my PPT now. I think my PPT is visible to all. Please confirm.
Yes, sir.
Yes, sir. Yes, sir. Yes,
okay. Thank you. So today we are going to discuss about IoT. What is the meaning of IoT and what are the application of IoT? And one of the wonderful car-sized computer is Raspberri Pi. And I'm going to deliver this task under the online refresher course of BPS Women University, titled E-Content Development and ICT Tools in Research. So these are the objectives of the discussions or this session. First, what is the introduction about IoT, the key issues in IoT implementation, introduction to Raspberry Pi, introduction to Python, because I will use some coding examples which is written in Python programming language, and finally we'll do some applications and programming of Raspberry Pi hardware using 3 different interfaces. One is the LED, another one is sense head, and the third one is the camera module. So IoT connects things, but also systems and people. Things includes machines, devices, sensors, consumer products, vehicles, etc. So if we are talking about the systems, include your business applications, ERP, CRM, PLM systems, analytic systems, data warehouses, and control systems. When we are talking about the people, it includes workers, consumers, employees, partners, and customers. So in broad sense, when we are talking about the IoTs, we not only think that we are just connecting the things, we also connecting the system and the people somehow. So we know that today internet usability, that is
Sir, sound नहीं आ रहा है सर.
Sound नहीं आ रहा है. कम आ रहा है या नहीं आ रहा है? Please.
कम आ रहा है सर. कम आ रहा है.
आ रहा है सर, आ रहा है.
नहीं, प्रॉपर है सर, साउंड तो है सर. हो सकता है सर गटप्पा सर आपके यहाँ पे कोई दिक्कत आ रही है.
हाँ,
इधर भी है.
गटप्पा सर आप पे हो सकता है थोड़ी इंटरनेट कनेक्शन, स्पीकर का इशू भी हो सकता है.
इधर साइक्लोन आया, उसके बाद ऐसे हो रहा है क्या सर?
हाँ, तो एक बार प्लीज चेक एट योर एंड सर.
Shall I start?
Yes, sir.
Okay. So today we know that internet is the place, that, or the technology which is, that common for all humans. And on daily basis, that every minute we are spending a lot of time, that on the internet. And amount of the data that we are generating somehow using maybe like YouTube, Every minute, 2.8 million YouTube videos are seen on YouTube. 2.4 million Google queries fired by the users. 150 million emails sent every minute. 21 million messages on WhatsApp. 51,000 apps downloaded from Play stores, and 7 lakh, more than 7 lakh Facebook connections are accepted every minute, and in such a way, huge amount of data is generated by the very popular applications because its number of users are very high. So, for example, it would take you 5 years to view all the videos crossing IP network each seconds. So, this is like amount of data which is generated on the internet. And now, why IoT is very popular? Because it you know that it increases the level of your comfort, your security, and you know that you have the smart cities concept right now in India as well as in foreign. And smart home applications are also growing exponentially. Smart parking lots are also there. Smart vehicles is also there. And smart healthcare is just one of the that coming applications. Population and calamity monitoring is very efficiently done using the IoT. Smart energy solutions is also possible, and smart agriculture is the new domain which is used to that the growth of the agriculture products. So when we're talking about the things on internet, let me discuss about the duration of the connectivity during 2000 to 2007. When we will go to the devices for perform the operations, like you want to send some email, you want to access some websites on the browser, and you want to search some items on Google. But now the tradition has been changed, and during 2007 to 2015, now things is internets of mobile. Means like now devices is going with you, like e-commerce, social media platform, local aware application. So you have the mobiles with you. So now devices are with you, and you can access the applications from e-commerce to location aware applications and etc. But during the 2013 to 2029, it is possible to provide the internet connectivity to the embedded systems, and it is actually generating the concept of Internet of Things. Now, object connected even without you. Okay. So meaning is that if you have a smart AC, if you have like a smart heater, and other so many applications of eco dots and something. So human involvement is not there for the connectivity. They are always connected with the internet without human intervention. So meaning is that now things around us is going to be smart in terms of that they are having the connectivity with the internet. And once they are connected to internet, that their applications, their uses maybe that has been increased exponentially. So, but Internet of Things not only connecting the things, it also connects the people, processes, data. And after 2029, we have in the ubiquitous world where there is a separation is a little bit blurred, who is connected, who is not connected, because almost all things are somehow connected to the internet. So this is the development of the connectivity of the things, and this is very important to understand that after some time, almost all devices somehow connected. So now, when you're talking about the IoT, why IoT is that meaningful? Because we know that in today's scenarios, the cloud computing is that it's very popular concept for getting the huge amount of processing power and huge amount of data storage capacity. And once you provided your physical object with some internet connectivity, that means they are able to that connect with the outside world. In that case, they can get the power, processing power, and the storage power of the outside world, like cloud computing platforms. Earlier, it was not possible because most of the embedded systems, having no internet connectivity directly. So I'm just giving you just one example that today we are going to discuss this device, this Raspberri Pi. And here you can say that, see that we have the Ethernet port here. Correct? It is a complete computer having everything that on it, and you can interact with the outside world with the help of sensors only using this card, because this is a complete computer. So if I can sense that outside world, and I can trigger some action, I can take the help of cloud computing using the internet connectivity, then the usability and application of those devices are multifold. So we need to understand that we have now network connectivity. It is not only the wired connection, it is having the wireless connection as well. So because it is having the Wi-Fi integrated. So this is something important, because cloud computing is growing, that this is economy of scale in terms of computing, in terms of storage, and many other applications from machine learning to artificial intelligence. So this powerful infrastructure is now consumable by the smart objects, that having internet component now embedded inside it. So now we are talking about the IoT, we need to think in terms of cloud computing as well. Because somehow these physical objects are limited in terms of the computing power and in terms of storage or data storage that you can maintain in those systems, because somehow they are limited. So they will take the power of cloud computing in terms of storage and computing, because of this internet connectivity possible with the objects, or we can say these are the smart objects. And now, since we know that because data centers are located very far, and cloud computing is providing storage and computing facilities, but somehow it is required that we require a time-bound responses. Fine. So a new concept are also coming is called edge computing and the fog computing. So now suppose you have this layer of sensors, and maybe some task should be responded in a very time critical manner. In that case, some amount of processing or maybe responses may be handled by the nearby devices, networking devices, it's called edge devices, so that some small portion of task may be handled just on the edge of the network. There is no need to move at the cloud, because there is a delay, and if you require some urgent responses, you can divide your work. Somehow small operations may be handled by the edge computing devices, and if you require some more power in terms of the storage and the processing, then there is an intermediate infrastructure is also coming, that is called fog computing. So somehow most of the small or very real-time operations would be handled by the edge or the fog. But if suppose you require a huge amount of storage and that processing power, then again it will be redirected to the cloud. So this cloud, this is also that it is semi-cloud, which is somehow the less powerful than the cloud, but it is good enough to respond to that your system in real-time manner. So sensor collects data, but where do you process? It's very important. That's why I'm telling that
Excuse me, sir, there is a question.
Yeah.
There is a two-layer sensor and IP network. What will be the interface of both to connect them, sensor layer and IP network layer?
Because these sensors layers are actually sensing, there are different physical parameters in the environment. Fine, and these are all devices related to the just networking concepts. Everything is related to the network, right? So these devices are located in the network actually. Fine. So that's why because these all devices having the networking capabilities, right? And these sensors are sensing the information and sending to the edge gateways. Correct. So that's why I'm giving these two layers, because they are located in far in network. Sensors are that are a local deployment. That's why I'm giving the like two different layers. This is sensor layer and this is IP network. So IoT WF, IoT World Federation standardized the IoT structure. There are also different models are possible, but this is one of the easy to understand. So here we have the physical devices and controller in layer 1. where we have the sensor, devices, machines, intelligence nodes for all the types. And again, at the upper layer, we have the networking connectivity devices, and we have the edge computing here, the edge of the network. We have then some data accumulation, storage of the data, which is sensed by the sensor and collected with the help of connectivity. And from this collected data, information is aggregated, and now it is available to higher applications to generate the reporting, analytics, and other control information, and which may be used by the collaborative applications, that at the top. So this is somehow looks like this is a OSI model, because but yet this concept is a little bit different. So actually, when we are talking about the IoT, we have the two stacks. One is called the IoT functional stack, and another one is the data management stack. So the core stack is related to the connectivity. So here things means you have the sensors, you have the actuators, and then you have the communication network, and at the top you have the applications. So the core IoT functional stack is the networking, right? And it includes the sensor, communication network, and the application deployed at the, that maybe on the edge, maybe on the fog, and maybe on the cloud. And when you're talking about IoT data management and computer stack, so we have this means we can process very near to the sensor layer, means on the edge devices, or we can also process on some upper layer of the networking, which having comparatively more compute and storage power, which is called fog, and the ultimate top layer is called the fog, cloud computing. So when we're talking about the IoT, we have actually two stacks. One is related to connectivity, another one is the processing of the or the storage of the data at different points, maybe on edge, maybe on fog, and maybe on cloud. And since when you're talking about the IoT, and there are a lot of technologies related to the connectivity, and we have the different ranges. But wireless connectivity is the dominating technology, which helping to make realizable this IoT concept. So now we are talking about what are the challenges of the IoT. So first one thing is the scale. And suppose you have the electrical meters connected across like 10 million houses, and you want to collect some data from those meters. So definitely, that the scale of application is, that very huge. So when you're talking about the IoT, you think that maybe you are sensing the information from millions of billions of points. Security of millions of interconnected devices. The devices which is collecting the information, we need to ensure the security of those devices somehow. Privacy. What do your things tell me about? So data, that is, that propagating from this IoT. So what kind of data and what kind of information of the user or the surroundings they are communicating, we need to protect somehow, because privacy is also a great concern. Big data, because millions of smart objects are there, they are generating huge amount of data. For example, if I'm collecting my room temperature every second, so you can understand that during the whole day, that how many seconds are there, and that number of records are generated by your temperature sensor. So if you want to just get the average of the temperature throughout the month, you can understand that how many records are there. So big data is definitely generated by the IoT platforms, and interoperability is also issues, because different companies offering IoTs, but maybe they are proprietary products. Okay, so interoperability is also issues, because if different IoTs offerings are that somehow supported each other, then only that IoT will grow that in a more seamless way. And OT-IT coverages, can operational technology use the same network as IT? But I'm not going to discuss all these things in detail, because we'll just focus on the the platform which students or the faculty can explore for their research and for their project Raspberri Pi. So first we need to understand what actually embedded system or IP do actually. So here are the three components, which is very important. First one is a sensor, like temperature sensor detects the heat. and we send this information in electrical form to some control center, some application. It sends this detect signals to the control center, and now control center send commands to sprinkler, and your sprinkler turns on and put out flame. So actually sensor and actuator, sensor sense the environment, and actuator is actually act, you know that, in response of the what are the information sensed by the sensor. So there is actually control center which actually process the reading of the sensor data, and then it will act accordingly with the help of some other devices called actuators. So what sensor senses? So sensors, different kind of sensors are possible or available, which measures the physical quantity and convert them into digital representation. You can sense the position, you can sense the motion, you can sense the velocity, force, pressure, flow, acoustic, humidity, light, radiation, temperature, chemical, and biosensors. So since there are huge amount of sensors are available, so that means many properties we can sense from the environment, and accordingly we can act. So now I would like to share my experiences with the embedded system during my education, B2 MTech, and then development of some ERP solutions for the my export clients. So in 2004, I have developed an embedded system entitled Guardian Angel for a house. And I have used the system 8085 microprocessor, and almost 8 different ICs I have used from RAM, ROM, and the processor and other peripherals. But it was, you know, that very difficult to program on EEPROM using assembly code, because we all know that assembly code is very difficult, and we cannot manage it for an efficient way. That's why there is only tool so now there is a good abstraction is required. So here you can understand, this is just illustration purpose. So this 1 feet by 1 feet board designed by me, including double-sided PCB and different processors and the memory and other controllers. But my experience was good, but it is very difficult to develop that kind of system. But in 2008, I attended one of the good course of IC Bangalore on 8085 microcontroller, where we use embedded C for the programming of the different hardware. But again, we have the difficulties because standalone we cannot work on 805 directly. So PC software was used to one program into onboard memory, and for each program we need to write into a board memory. Seriously, it is a very difficult, because at a time we need to handle with the two systems. One is the embedded board, another one is my PC. So somehow it was very complex, and this is for this illustration purpose. 8051 board, we have a lot of interfaces, and we connected this particular board to the computer, and then we write some program using embedded C in my system, and then I put everything, you know, that into this board, and then we need to you know, that execute the code, and we'll just test the functionality that we have written in embedded C. So again, when you're talking about the number of hardwares I'm handling, you know that this is somehow very complex, but it is definitely better than the assembly code program. In 2011, I presented a paper in international conference related to cloud robotics for disaster management. So when we have ample of power in terms of cloud, we can store very huge amount of data, and we can process large amount of data in very efficient way, because we have the data centers, which is very powerful infrastructure, comparison to embedded systems available. So if embedded devices, maybe your mobile devices, maybe your robots, or maybe other kind of embedded platforms, if somehow they are connected with the internet, in that case, the huge amount of processing, that can be performed on the cloud. So indirectly, we are actually increasing the capability of it, robots or the embedded systems, if they are somehow connected to the internet. So nowadays, now we can, and the same work is also cited by the University of California, Berkeley, in their survey report. And they are also working on this cloud robotics, and now this term is going to be very popular because somehow, if we are developing a robot which is having more and more features, then definitely cost is going to be very high. But if we want to divide this workload between do some processing of urgent nature, that in the robot itself, and do some processing, for which you can expect some level of delay, but you are getting a huge amount of power in terms of storage and compute. So this way you can, you can manage, you can generate the less expensive embedded devices or the robots. So networking is very, very important. In 2013, I have interacted with a new platform which is called Raspberri Pi. I write my first program on this card-sized computer, and it is very easy to program than earlier embedded systems, and power of networking and multiple USB ports. So I already displayed you in the start of the session. The networking changed the life, or the way the products are designed in industry. So what is the beauty of this product? You have your operating system installed in this device, correct? And if you want to program it using some programming languages like maybe your C, C++, maybe Java, or maybe Python, you don't need to buy expensive hardware. Okay, that means you can program this computer with the help of your existing monitor, right? And your existing keyboard and mouse, and only thing you require is a micro SD card. Additionally, if you connected all these things, you can program without purchasing the expensive hardware in terms of your laptop, your PC. So this is a beauty. So now everything is that in just one hardware package, and now we have the different models of this Raspberry Pi, from Raspberry Pi 0 to Raspberry Pi 4, and right now that the current offering of this Raspberry Pi is in 8 GB version. So you can understand the power has been increased significantly from 1 GB of RAM to 8 GB of RAM. And I mostly recommend people or the students, that if you want to experiment a lot of technologies, like if you want to learn Linux, and suppose you have no PC at your home, and if you have no laptop at your home, you need to just buy just 3,000, 4,000 this computer, and you need to just arrange just one monitor, maybe old monitor may be there, you can purchase the new one, and the keyboard, mouse are easily available. So programming this device is not complex in terms of money, and in terms of the interfaces provided by the platform. So the Raspberry Pi is a teeny and affordable computer that you can use to learn programming through fun and practical projects. So here you can see this is an Ethernet port, and right now offering is like it supports 1 GB networking, and you have USB ports. Earlier one they are the USB 2, and now USB 3 and 2 both are available. And these are the pins, which is a general purpose input-output pins that we can use to control the outside world. We can connect the displays, HDMI monitors we can connect. And suppose if we don't have the HDMI monitor with us, we have the old monitor with VGA cable. So you have this adapter which actually transforms your VGA signals into HDMI signals. So using this hardware, your existing hardware can be, or old hardware can be replaced without any problem. So now I'm just going to discuss about the Raspberry Pi. It is launched in 2011. The Raspberry Pi has found a role both as a very low-cost Linux-based computer and as a platform for embedded computing. Till date, more than 20 million Raspberry Pi have been sold. The Raspberry Pi 4 is an option 4 GB. Earlier it is 4 GB, but now they are offering 8 GB as well as. Our performance makes the Raspberry Pi more than powerful enough to use as a replacement for a desktop computer. I'm also researching this Raspberry Pi for my PhD to provide some level of security in software systems. And these are the different models. Here you can see from B plus A plus, where we have this RAM of just 512 MB, and it is that continuously upgraded. Small footprint is also available in terms of Raspberry Pi 0 and 0 wireless. And recently, Model 4 is launched, and now the new version is also launched, in which everything is that in the keyboard. Everything is just in one keyboard. You need to just plug monitor and then plug your mouse, and then you need to start your program. So, well, this platform is not only supported by the Raspberry Pi Foundation or their product, means Raspbian or Raspberry Pi Desktop, but other big companies is also offering operating system for Raspberry Pi. Ubuntu Mate is there, Ubuntu Core is there, Ubuntu Server is there, and Windows 10 IT Core is also supported on this platform, and likewise many other OSs also available. So this is a very trusted and very supported product by the industry. So this is a micro view. Here you can understand we have these 40 pins. It can be used for general purpose input-output programming of electronic components. Ethernet port is there and USB port. In the latest model, we have the USB port 2 and USB port 3. We have audio jack to play audio, and there's a camera module port where we can connect camera and we can program using camera. We will also discuss during the next session about all these things. And we have two HDMI port. That means we can play or we can use two monitors simultaneously using this small computer on 4K quality. And this is a power, micro USB power. Now the latest version having Type-C connector. And we need to just insert micro SD card here. There's a slot for micro SD card. So every data, your operating system or the file you are storing, that everything will be available on this micro SD card. So this is a very, that cheap storage in terms of the hard disk of the PC. And also somehow you are limited because you cannot move easily, that hard disk for your laptop or your computer. So if you are designing some kind of prototype, in that case, this product is very successful, because if you want to do the different experiment on different operating systems on this hardware, so I need to just purchase the micro SD card and I'll run that the different operating system or the different products on just micro SD card. Rest of the things will be same. So it is very easy, that to experiment or to prototype on an isolated system. So I think 300 or 500 rupees micro SD card is enough for this. And these are some specification of Raspberry Pi 4 product. The processor is from the Broadcom PCM2711, quad-core Cortex A7 ARM V8 family, and it is a 64-bit SoC, system on chip. So means that you have GPU, you have CPU, you have memory. Everything is that embedded in a complex design, and the system on chip is now companies are designing at nanoscale, that level. Means nanometer technology is there. So now there is more and more components are that diffusing that in chip, and it operates at 1.5 gigahertz. It supports the different memories of LPDDR4 from 1 GB to 8 GB. Now recently they have changed or updated the memory up to 8 GB. And different kind of connectivities there. Wi-Fi you can connect, Bluetooth you can connect, and gigabit Ethernet connectivity is also possible. And it provides the USB 3 and USB 2 ports. This is the latest Broadcom Video Core 6 GPU available there. And video and sounds you can play at these standards like H.264, H.265. And microSD card for loading operating system and data storage. And mostly you need to purchase microSD card of class 10 and above. And input power is 5 volt, and GPIO is of 40 pin standard. Operating temperature is 0 to 50 degrees centigrade, and this product is supported up to 2026. And this Raspberry Pi is passed through many reputed benchmarkings platforms like it is like good performance on Limpec benchmark. Python GPIO 0 is a very excellent library available with the Raspberry Pi. File compression is very speedy, and speedometer performance is very good. And GIMP image editing you can also do on this platform. And USB storage throughput is also very good. Very good memory bandwidth. Ethernet throughput is like up to the 1 GB. Wireless LAN throughput is comparatively better than the earlier Raspberry Pi versions. And thermal performance is also very good or distributed on the board. But there is only one significant thing, as since we are getting more power, more processing, so a little bit power draw is that little bit high. But in comparison to other parameters or the enhancement, the product is very nice. So if you want to set up a system for Raspberry Pi, what we require actually? We require a Raspberry Pi 4 or of different with different memory capacity, and we require a power supply of 5 volt and 3 ampere. USB Type-C connector is there. Micro SD card is required. Minimum 8 GB is required, and class 10 is also there. Operating system, there are many operating systems you can install, but I'll demonstrate today with the Raspbian operating system provided by the Raspberry Pi Foundation. And USB keyboard and mouse is required for interact and for the input. Micro HDMI cable is also there, so that we can connect to the monitors having HDMI connectivity. But suppose your monitor having no HDMI connectivity, there is no issue. You can use the adapter to convert your VGA into HDMI, and you can use your old monitor. There is no issue at all. Ethernet cable is required if you willing to wired internet connectivity, but wireless is also there. So if you have the Wi-Fi available nearby, you can also connect with the Wi-Fi. So this is the ultimate system connected view. So this is a power point, and these are the two monitors. And I will use just one monitor now. And this is the audio jack USB. So this is all about the system. Most of the hardware that you're connecting is available that here home. So you can just purchase a board and you can start program. And this is the GPIO Pin Diagram, it's a 40 pin. And these GPIO pins are actually general purpose, and you can use same pin for the input mode and for the output mode. Okay, so this diagram should be in your mind. So mostly I will use this pin third for the ground to demonstrate some LED programming or handling the LED, and and this like 12 number pin I will use. GPIO 18 I will use. Fine. So please be remember these are the physical pin numbers, but they have the nomenclature as GPIO 18. So GPIO 18 doesn't mean I'm talking about the pin number 18. Fine. So mostly in programming you need to interact with the, or you need to write these identification, not the exact pin number. Fine. So these GPIOs are very important. So I will use it to do some kind of program. And important points before interfacing, interacting hardware or interfacing hardware with Raspberry Pi 4. First of all, do not power the Pi with more than 5 volts. So mostly use the recommended power supply provided by the Raspberry Pi Foundation only. Always connect a Raspberry Pi ground pin to the ground connection of whatever devices you are attaching. Do not put more than 3.3 volt on any GPIO pin being used as an input. Do not draw the more than 16 milliampere per output. Keep total for all output below 50 milliampere for an older 26 pin Raspberry Pi and below 100 milliampere on 40 pin Raspberry Pi. When using LED, 3 milliampere is enough to light an LED, and therefore you need to just use the 400 and 500 on series register to glow in LED enough with enough brightness. And do not draw more than a total of 250 milliampere from 5 volt supply pins. So these are the precautions that you need to remember, otherwise you can damage this product. So I think before going up, I will just interact with the Raspberry Pi. So I will start another video, another camera to demonstrate a small lab that I have set up. So this is small lab I have set up for today's session. So I will connect all these components and I'll show you. So what kind of efforts are required to on the system? I think it is visible to all. The system is visible to all.
Yes, sir.
Yes, sir.
Okay. So I have this card with me right now. So there is a that box for it. I will place a Raspberry Pi inside it, and at the down, I will just insert this micro SD card. Okay. So micro SD card is inserted. Now this is Type C connector. I will connect at this point. So now monitor is connected. And there are two things I will do. I will connect keyboard. You can use any keyboard. Right now I am using the official keyboard of Raspberry Pi Foundation. So this is the whole connectivity. You can see this is your CPU, you know that. This is everything is this CPU, your monitor, this mouse, and only this keyboard. And just I'm going to on this machine. So I started. So it is a complete system having all the facility of programming. You can, that you browse the internet. So here is a browser. Like I'm accessing my company website. Wi-Fi is already connected. So I'm connected with the Wi-Fi. If I want to do the programming, I have the terminal here. Okay, so I can list all the files. So this is completely Linux-based platform. So what is the beauty of this product? That everything is, that is just in one hardware. You don't need to just use a different PC, or different laptop to anyhow interact with this device. Okay. But for the more demonstration purpose, because we are online streaming right now, so I will use some another mode to interact with this device. I will use a VNC viewer to interact with this hardware, so that I can demonstrate you a lot of things, that during the session. So I'm sharing my screen. So I think my screen is now visible to you.
Yes, sir.
Okay.
Yes, sir.
So please see carefully what I'm doing. I'm just launching. I'm just launching the VNC viewer. So I just launched it, and since the IP of my machine is like this, Raspberry Pi IP is this, so I just double click it. So now we can see that remotely I am accessing Raspberry Pi here in the video. If you can see, fine. So I am handling this Raspberry Pi from my machine. Correct. So what you need to do? One important thing is the configuration. So here you can move in the preferences, and this is the Raspberry Pi configuration. And this kind of access of VNC is only possible when you enable it. That in Raspberry Pi OS, Raspberry. So you need to activate, you need to enable VNC server, so that now we can connect with the help of VNC client. And you can also assess it if it is enabled. And if you want to do some programming using camera, you need to also enable it. And there are other things also available, but I will just use this camera feature right now and this VNC to demonstrate you things more practically. So this is everything that related to Raspberry, and I'm accessing this operating system at my machine. So just now moving on the presentation. So before doing any kind of programming using Raspberry operating system, a little bit knowledge of Python is required. So that's why I have added here, like variable I have added. So these are the way, like in PHP, you can declare variables. You don't no need to write the data type. According to the data type, implicitly they will get the data type. That means here is that is a numeric, means int, not is float, and like this. So this is a little bit different than C language. If you want to print something, you can just write print x. If you want to get something from the user, you need to just use this function, but it will give you the information in terms of a string. So if you want to use the information of this variable in numeric form or in the integer way, you need to cast it and you can make a formula to getting the Fahrenheit temperature from the centigrade input. In the same way, if you want to do some kind of if-else checking on the variable or the constants, this is the syntax. If x is greater than 100, print x is big as x is small. And if you want to iterate using some loop like for loop, you can specify things like this for variable I in range 1 to 11. So now I will move from 1 to 11, and in the meanwhile you can print the information inside. In the same way, you have the while loop. So the syntax is like this: while the condition is true, do some kind of iteration. Here we are getting commands. One user input X and outside this loop. Okay, so the logics are same as in your C, C++, or Java, but little bit syntax is different. But main concept of algorithm would be same. There is no difference. And you can also define your function. You need to write this that keyword, this name of your function. You can provide some default values and do some kind of processing. And this is a way to call the function. So count to n 5. So n will get the value of 5. Accordingly, it will move from 1 to 6. So I'll get the value 1, 2, 3, 4, 5, 6. So this is the way we can define the function. If we are playing with the set of items, in that case we can create a list. So here I created a different kind of value list. Means some boolean is there, integer is there, float is there, string is there. So that kind of complexity is possible, which is not available, that in C or C++. And we can enumerate the list, like there are different items. I can enumerate in terms of index and the value at the index, or I can iterate just on the value. So these are the two syntaxes. And if you want to format some existing variable value or some constant, the formatting is also possible. So this is just for the motivation purpose that there is nothing big in the Python. If small we want to write and small we want to program. So first, I would like to demonstrate to you about how we can program to just blink an LED with the help of Python, program editor in Python or Raspberri Pi platform. So here you can see this is a positive and this is a negative, and since this is a ground, and you know that in this specification, GPIO pin specification, the third pin is the ground. Right. So this negative is connected here, and this is positive, and positive I will connect on this GPIO pin 18, but physical pin is 12. Be careful. So this 18 number is related to the name given to this pin 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So physical pin is 12, but nomenclature, in nomenclature it is called GPIO pin 18. Fine. So if you make this connectivity, and if we are doing some kind of programming, or you are giving some kind of voltage switching, means 0, 1, 0, 1, 0, 1, in that case, you will get the effect on this LED. So what we are actually achieving, that if we are able to, that switch LED with the help of programming, so meaning is that we can trigger any devices. Maybe LED is there, maybe relay is there, which is that controlling some other devices. So this is the beauty. Actually, we are actually controlling the external hardware with the help of programming, and one of the cards is board called Raspberry Pi. So this is a very small program. How we will achieve it? You need to create a Python file .py, and first you need to import some class, LED class, from this library GPIO 0 module, and you need to use one function called slave from this time module. So this class and this function is that is useful, and this is from where your program actually begins. So you specify you are connecting this LED on pin number 18. Okay, because the different inputs you are providing, output you are providing, that on pin number 18. to control this LED. So once you instantiate this class using this constructor, now the linking of this particular pin is in this object LED, and when you call function on and off on this LED object, you know that with this slip, so you have your LED will be on, then it will be slip for 2 seconds. So meaning is that it will be on for 2 seconds, and again this function is called. So now LED will be off. So this is small program, you know that I'm just going to play on Raspberri Pi. So if you want to see the source code, it is available here. You can see. So this small code is enough to control an LED or control any device in output mode because you are controlling the output word, correct? Now, I'm just going to connect the hardware. So I have this small connection. Okay. So these are the pins, correct? So I need to identify 2 pins. Positive will be on pin number 6. And negative will be on pin number 3. So I am connecting the ground. And now six is here. So this is a positive. Fine. So now things are connected. Will you please anyone confirm my video is visible? My video is visible?
So the camera is visible, but it is very small.
Means Raspberry Pi is visible to you or not?
Yes, sir.
Okay. So now there is a lot of editing platform. So there is a good editor called Actuator is there for writing Python programs. Okay, and so I have already opened this is a small program, LED test program. Okay, it is visible to you? My screen is visible?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So just look at, I just started and just see in my camera as well. So I just run it and you will see that LED is on for 2 seconds. So don't worry, I'll make this time a little bit longer so we can see that. So now LED is off. Can anyone confirm LED is off?
Yes, sir.
Yes, sir.
Okay, so I just running it and you see that now LED is on for 10 seconds.
Yes, sir.
and after 10 seconds, it is going down. Okay. So meaning is that how much efforts is required to control some device with the help of Raspberry Pi? Only just 6-line code is enough to trigger a device for 10 seconds. Right? You require just one board of like 3,000 or 2,000 rupees, depending on what kind of version you are purchasing. So this is like one sort of program. And now I will demonstrate some other programs.
Excuse me, sir.
हाँ
सर आजकल जैसे ये सेंसर वाली लाइट्स आती हैं कि कोई आगे ऐसे चला या जा रहा है तो वो ऑन हो जाती है 5-10 सेकंड के लिए या 20 सेकंड के लिए ऑन हो जाती है, उसके बाद अपने आप ऑफ हो जाती है, तो उसमें भी यही सिस्टम लगा हुआ है?
हाँ बिल्कुल, ये टेक्नोलॉजी, इसी तरह की टेक्नोलॉजी यूज होता है. इट डिपेंड्स ऑन व्हाट हार्डवेयर दे आर यूजिंग. करेक्ट. वी आर यूजिंग Raspberry Pi, maybe they are using Arduino or other hardware. Correct.
Okay, sir. Okay.
So, but this Python is universally, that accepted today in all hardware platforms.
Fine, sir.
I think little bit issue. I'll launch my PPT once again to show you that. I have a lot of programs, but it is not. No problem, I will show you from the different PPT. Let me check. So this program we have already discussed, and so this is another program for LED building. So when you are controlling the LED, your system is busy with this LED, so you cannot do another kind of task. Fine. So here there is another function called LED blink function. Fine. So here you can control on and off your LED, and this operation is controlled in different thread. So meanwhile you can do another task as well. Okay, because in the complex system, just controlling this one device is not enough. You need to control many devices. So this is just that controlling this blinking in different thread, and now your main system is free to do another task. So this is that kind of code. So it also I can demonstrate. So here LED blink function is there. Okay. I'm stopping it, and now I'm running it. Right. So here you can say LED is blinking. It is visible.
Yes, sir.
It is visible, and you can see that now I can interact in ID at downside. So I will write something and then enter. Okay. So now LED is off. Meaning is that I'm doing different operations simultaneously. Okay. So when you want to do some complex job or controlling the different devices, so just PC with just one device is not enough. Correct. You need to control many devices. So your system should respond to different device interaction. So in that case, that kind of code will help you. Now I'm moving ahead. This is the code. And now if you want to control the LED brightness, so there is a very small code. So it is like you have the brightness from 0.0 to 1. So I already explained this code. This while loop is infinite loop, right? I created this PWM LED class object LED on pin number 18. It's same thing, but it is a PWM LED. So we can just change the that width of the pulses, right? So what you are doing in this program actually, you are inputting that brightness from 0.0 to 1, and accordingly the LED brightness will be going to change. Right? So here you can see we have another program, LED brightness control. No problem. I open it from a folder. There is a folder in which I have set up all these things. Desktop. You can go here in workshop and task. This is identity. This is infinite loop, so you can make your LED on and off continuously. Here you can see. Here you can see you have the sleep of 2 seconds. So you have the interval of on and off is like 2 seconds. So it's look like it is like blinking. Correct. So important thing is what your while loop. So now I'm just going to stop it. Now another is LED brightness control. Okay. So here I'm just going to run this program, and it will ask me to enter the brightness. So here you can see I just enter like 0.5. So my LED will be that half on in terms of brightness. So if I'm just going to enter 0.0, LED is off. Okay. And if I am just providing 1 as input, you will see it will be on for full brightness. Okay, so this is something to show that how easy that we can control that or we can provide the different level of voltage that to control the devices. Like you want to control the speed of the fan, that means you need to just regulate your you need to just change the voltages at different scale. So you can do the same things that with the help of this Raspberry Pi. So ultimate purpose is that if different variation of voltage is required to control a device, it could be easily controlled by the Raspberry Pi. So I'm just going to stop it and just moving very interesting examples of controlling things from the graphical user interface. So we have 2 programs here. This is very interesting. Now you have interface to control your devices with the help of GUI programming kind of concept. So here you can see I created this digital output device on again same pin number 18. Okay, and I will use 2 different classes to add a window application is app and to add some push button. In this window application is push button. So I created 2 functions here. I defined 2 functions, start and stop. Start will on the LED, stop will off the LED, and accordingly the buttons will be enabled or disabled. So if your light is already on, there is no need to make enable on button. Definitely off would be enabled. Okay. So this you have this constructor call. So you have the 10/150 size window. Name is push button. You will create the start button and end button with the caption on and off. and you will integrate both buttons in the application, correct? So you have both buttons embedded in the application app, and now you will make this application available. But when you press those buttons, start and stop, correspondingly, that function will be called, and accordingly you will get the effect of switching on and off your devices with the help of user interface. So see, this is one of the very beautiful program. So here you can see that now you have the user interface, correct? And again, see the board, you see the LED is off, but when I click on, it is on. Okay? And when I'm pressing off, LED is off. So this somehow increasing the different dimension. Now you can control the object of your devices. You can trigger your devices on and off with the help of your PC. Correct? If you have the proper configuration, fine, you can easily control your home devices from your computer monitor. You no need to switch any button, but you need to do necessary, that connectivity between the devices. So I think it is visible on and off. Hope so it is visible.
Yes, sir.
Okay.
Yes, sir.
So like this is the beauty, that of the technology, and in terms of IoT, we are easily, without touching the devices, switches, you are controlling the devices, correct? And there is another good example. There is a UI slider. If you want to control the speed of the fan using your desktop or your PC, or if suppose your application is that on net, so आप अपने ऑफिस से कंट्रोल कर सकते हैं devices like this. So here I am using the slider integrated in this application, and according to the value of the slider, I'll get the percentage of the brightness of the pin. Okay, so here you can see, once I run it, actually I will get the slider. So this is my window application, and I have the slider, and here you can see on this board. So LED is off, fine. But once I drag it, the brightness is going to increase continuously. Speed upload. So here 100, it is down, and it is off. Okay, so it depends on you what kind of variation you require. Okay, so if you want to play your devices in range, like your fan, or any devices that you want to operate at different voltages, in that case, the slider GUI is very helpful. If you want to trigger your devices in just binary mode on and off, in that case, buttons are good ones. Correct. So what ultimate I want to demonstrate, it is very easy to create a dashboard at your home PC, fine. And if you have the appropriate hardware connectivity, then you can interact with any devices with very ease, without moving or without leaving your seat. Means just sitting at your PC or laptop, you can control your home without any issue. So this is all about LED-based programs, and so LED is the example is like you are interacting with the outside world in output way, fine. You are sending some signals. If you want to detect the motion around the PIR center, PIR sensor, in that case this kind of connectivity is required. And once you configure it, and if you write this small program, you have the class motion sensor using from this library GPIO 0. You set this motion sensor on pin 18. Pin 18 means just GPIO 18, but actual physical pin number is 12. So once you create this while loop for infinite time, and you are calling this function PIR, on this PIR, wait for a motion. So once there is no motion, you will be asleep at this point. But once motion is detected, it will print a message, motion detected. Okay, so if according to the proximity, suppose you want to control the light of your light of different rooms of your house, then if you set up this kind of configuration, if somebody is that inside the room, then your light will be on, otherwise it would be like off. Okay, so that kind of applications are including. Also, even in AC, that you have this kind of feature, proximity connect sensor. So before going up, sir, I am requesting for 5 minutes break.
What, sir?
Sir, I required 5 minutes break. Sir, I required 5 minutes break.
Sir, now we can have 15-minute break.
Okay, no problem, sir.
And at 11:45, we will be
Okay.
there again.
Okay, sir. Thank you so much.
So please be there at 11:45.
Okay, sir.
That's fine.
Okay, sir.
Okay, ji.
Okay, sir.
And now it's very interesting to understand the different functions for PIs. So now I will go for the break. Sir, shall I start? आवाज आ रही है सर? हेलो, आपकी आवाज नहीं आ रही सर? हाँ, हेलो, क्या?
हाँ जी सर मैं ये कह रहा हूँ 2-1 मिनट वेट करते हैं, दे पीपल्स आर ज्वाइनिंग।
Okay, no problem,
आफ्टर
no problem.
आफ्टर 2-3 मिनट्स यू मे स्टार्ट।
11:50 पे करते हैं सर, 5 मिनट के बाद, ठीक है?
ठीक है सर, ठीक है,
Okay.
क्योंकि अभी वो धीरे धीरे आ रहे हैं।
ठीक है, आने दो सर। करें सर, स्टार्ट करें?
यस सर।
ओके, थैंक यू। So we have experimented with the LED, and Now we are going to experiment with another hardware, and this hardware is sense head, having a lot of sensors embedded on it. Like temperature sensor is there, and humidity sensor is there, and velocity or direction sensors are there, and it has 8 by 8 LED matrix, which is programmable. And what you need to do actually, like this is your Raspberry Pi, fine, and you have these pins, you have GPIO pins. You need to just add, these, that the jack into this. And after that, you can do the programming. Okay. So symbolically, that I was just showing you all these things, and now I will add it on my real Raspberry Pi, so that we can further proceed with the next slides of sense set. Well, so I'm moving to my new camera of Raspberry Pi, and you will see that I'm just going to add this sense hat service, which is developed by the Raspberry Pi Foundation. And it's connected. There is someone looking to check it. Whether it is proper or not. So I'll just remove the connections. Just checking. Okay, that's perfect. Perfectly added. I will add my SD card. Micro SD card. There is a check. And the two cables, one is the power, and another one is SDI. So now setup is ready, and I'm just going to on this now. So, now this is sensor Raspberry Pi hardware attached on top. The sensor is an add-on board for the Raspberry Pi, made especially for the AstroPi competition. The board allows you to make measurement of temperature, humidity, pressure, orientation, and to output information using its built-in LED matrix. So this is programmable LED matrix, right? And we have the different sensors. This is gyroscope, exoscope, and this tip for measuring the humidity, and this is for the pressure. Okay, so all LED sensors are even that available on this hardware board, and this is one of the beautiful functionality of programming this 8 by 8 matrix of LED. So this is the way to interface this board on Raspberry Pi. You have this jack and just insert this jack into the GPIO header pins. And the LEDs on this board having the same coordinate system as in your two-dimensional concept. It starts from 0. So suppose if you want to glow, that at this point. So here X is 0, but Y is 2. And if you want to glow, and these LEDs are not normal LEDs, they are actually RGB LEDs. So you can put any color on those LEDs. Right? Suppose you want to color this point 02 with blue and at this point 74 with red. So this is possible with the help of this excellent tool. And these are the different sensors available. Gyroscope is there for detecting which way of the board is, accelerometer for detecting movement, and magnetometer for detecting magnetic fields. And due to these kind of sensors, that three kind of different motions are possible to detect. And what is the pitch and roll, and you can understand, that all the three parameters with the help of this diagram. So movement around this axis is called yaw, and movement around this axis is like a pitch, and moving around this axis is called like roll. So these different directions, that we can measure, that with the help of this smart board. So now this is a sample program of the sense set. So you have this library sense set, and you need to just import it. And a specific class sense set, you need to import it from this library, and you need to instantiate and get the object of the sense set. And now we can define two colors using array. So this is the RGB pattern, red, green, blue. For blue only, you have this parameter 255. So you have the values of 0 to 255 for different shade of blue. Okay, so it is that means these LEDs can generate any color, any universal color, because each color having values from 0 to 255. So definitely we have three components: red, green, and blue. So you can achieve any color. And suppose you place your hardware in such a way, and you require, you think that the text which is that is displaying that the board is not up to the mark, or you require some 90-degree or 180-degree shift. So this is also possible, just calling this small function sense.set rotation 180. If you want to show message at a time, only one character will be displayed. So I just mentioned this string here, and I'm just showing this. Its calling speed is 0.2, and text color is yellow, and background color is light blue. So on background color blue, text will be displayed in yellow, and they will be scrolled with the speed of 0.2. And once my work is done, sense set should be shut down. All LEDs should be that switch off. Otherwise, there is ample of heat generated by this board, or it can damage your Raspberry Pi. So be careful always playing with the sense set. Please close that your sense set LEDs. Just calling the sense clear method. So I created some code. I'm just moving again on Raspberry Pi. On this Raspberry Pi, we have different programs for SenseAct. We have sensor. I will show you first in this slide. So this sensor character output program is there. So small program, you have some set of characters, okay, and you display characters in different colors, and you define colors with the help of array. And these three values are a combination of red, green, blue. So in case of red, you have only this high, rest are 0. In green, this green component is high. In blue, this component is high, last row, and in yellow you have the combination of red and green. So these values are high. So in that way, universally will define any colors, that. And after that, if you want to show any character, there is a method called show underscore letter, and you can specify what is the character and what is the color of the character. So like here, I'm just showing these 4 different characters in that in different colors with the help of this. So I'm going to show you. So actually, I want to display your university name, GPSW, with the help of this board. So you can see here in camera. I'm just going to play it with 2 seconds of delay. Let's see it. So B, P, S, W, U in different colors. So what is the that beauty of this board? You can write any character or you can scroll any messages with using universal color. So this is another dimension of programming analytics, because this is also that part of comfortable lives or user choices to showing the text in different colors, right? So you want to buy the different LEDs or different colors. You have the programmability, and this is universal LED in which you can perform and develop any color. You have to just specify the color combinations of red, green, blue, and you will only this 8x8 matrix is enough to give you the any color character on the fly. So this is the purpose. And now this is sensor pixel manipulation. So here you can see the things are same. I just defined 2 different colors, and I just set the color of the pixel. This coordinate 0 2 is blue, and this is what red. So again, I'm just going to open. You can see sense hat pixels. This is sense hat pixels program. So stop it. Now you can see I'm just going to run it for 5 seconds. The delay is 5 seconds, so you will get the impression up to 5 seconds. So here you can see, according to the coordinates, 2 different points are bright with different colors. So as you have said. Okay, so this is like one of the things. But another thing I already explained that using this sense hat create a lot of it. So please use this thing that intelligently. And another important thing is that there is a very good application available on this platform called sense hat emulator. So you don't need to that buy this hardware. Even if you want to practice some programs, you can that perform the same programs or execute same programs with the help of emulator. So how this emulator will work, I'll show you. So this is a sensor emulator pixel manipulation. So, and this is a program. You need to just write sense hat EMU library in place of sense hat, right? So in that case, that you will emulate all the operations, that on the system without using this hat. You have some software actually which emulate, that the behavior of the sensor. So rest of the code is same. There is no difference, but you are using this sensor class from sense EMU library in place of sensor library. So let's see, sensor emulator. So here is sense hat EMU. So it's this topic and send it. So, I'm just going to run it and you see that. So you have emulator movement, and the corresponding that pixels are that bright with different colors. Okay, so this is a software application which actually emulates the complete behavior of the hardware of sense head. You need to just do one change, just import sense head from the library, sense EMU in place of sense head. So here you will see that all the effects that you want to achieve on the hardware. So this is a costlier way to interact with this hardware. And then some other programs like random colors. Again, it's like some image display. So how it will work? So if you want to display some image, so you write the different colors, and this is like one-dimensional array, and 8x8 matrix is there. So be careful. This is like first row and then second row and third row and fourth row. So what image I have set here? I have set the flag image, Indian flag image. So I will show you this in an emulator because rest of the things are same. There is no difference. This is sunset. Sunset image. So I'm just simulating the behavior is same. So here you can see that there is Indian flag. I decorate those LEDs in orange and two bottom rows, that in green, and like this. And I can run it again. So that means you can program these LEDs to that create some features, and there are big board are also available where you have 16 by 16 or 16 by 32 array of LEDs. So you can design that any image that electronically on this board or maybe other boards or LEDs matrix available. Another program I have designed for to display some smile. You can say some smile picture is here. So now you can see. So this is look like some smile is there. So it will be that displayed on the LED because LED display brightness is that very high. So you may not be able to see clearly that on the camera. That's why I'm giving you that examples on that is board on the emulator. And if you want to create some kind of movement in image, the flip is also possible. So here you can understand how flip look like. So you have the corresponding. Here you can see that this rectangular box is moving around. So we are doing nothing. We are just doing some kind of flipping and how this flipping will work. And here you can see I'm using this flip horizontal and flip vertical function. So any geometry you have specified that will flip horizontally and vertically. And now next is a head sensor display. So I already explained that the different kind of parameters like heat, temperature sensors can be sensed by this board. So you can just call these functions get temperature, get pressure, and get humidity. And now you can see all these information. You can create a string to show you like T column and then what is the actual temperature, P, and then what is the pressure, and H, what is the humidity. And once you construct this message, you print this message in this calling way using the show message method. So I'm just going to run it, and here you will see that it will show me the temperature like this. So here, if you want to change those parameters, so here you can see, I'm just going to change this temperature, like temperature is like 18 degree, fine. So here you can see, now your temperature has been changed. So now you have T, and this temperature is 18 point this. So this is very, that excellent, that software with which you can play and program and write very good code without buying any hardware. So this is also possible. And another operation is your actually joystick operation. Right? You have the joystick hardware on it. So how it will work? This okay. And before that, we have this temperature warning program. It is also very very good program to show the temperature warning. So you just run it. I'm doing nothing, but I'm just changing the background. That if my temperature is beyond 40 degree. So here you can see, since my temperature is, you can see it's less than 40, but suppose I'm just going to increase it, and you will see that now after this scrolling, my background has been changed. Okay, so this is the way we can present our information as per our requirement. Correct. So even I can sense the temperature of my Raspberry Pi when using this. If temperature is going beyond 40 degree, because at 45 degree almost more than 45 degree, it is dangerous for Raspberry Pi. Okay, so if you are using sense set, always sense if your LEDs are glowing and that your chip temperature is beyond 40 degree, that there will be risk. Fine. So this can be also used to sense temperature nearby Raspberry Pi, whether it is in working safe zone or not. So this is one of the program. Other one is the joystick program. So we have joystick program here. Joystick corrector. So I just going to run it. And you will see that we have the joystick. These are the joystick buttons: this top, down, right, left, and this is the middle. So once I press this, so to demonstrate, I will minimize it because okay, no, we are showing the key impression on the matrix. So no, there is no issue at all. So this is upper, this is down, this is right, this is left, and this is in middle. Okay, so that means you can enjoy with the some kind of control, having some kind of joystick hardware interface. This can be also possible with the help of this small code. So there is LED matrix programming, that, and joystick is also there. Temperature, humidity, pressure kind of operations can also be performed. So this is really a very good board to experiment. So this is the small code. So you are just getting the events from the sense set using sense stick and get events, and this is the infinite loop. So it will sense the events always. So once it found the event pressed, it will show the message accordingly. And if it is pressed, then which direction is pressed? What direction that it is pressed? Maybe up, down, left, right, in the middle. So these code and these resources, that all are that available on Raspberry by the organization website. It's nothing complex. Okay, so this is all about the sense set. Now I'm going to discuss about a new interface or new hardware. How we can program your camera. So to integrate camera, what we require a camera module, fine, and you can add this camera module in this camera slot. Okay, so just out this is a black strip, fine, and then facing this yellow bar towards Ethernet and the metallic contact towards HDMI ports. Okay, so this is the way you can connect. Just insert it and then again press this black slot. So now it will be fixed, and now you can experiment with the camera. But before using camera module, be careful. It should be enabled. Okay, and since we are interacting remotely, so VNC is also enabled in our case. And if you want to perform some remote operation, you want to copy some file, you want to write some file. If you want to move file around, you know that across different systems, SSH is also possible. So these are some commands that I will perform. But before you know that doing that kind of programming, I need to connect the camera module with it. Okay, so first of all, I need just 1 or 2 minutes to switch on the existing system and then connect the hardware. So just please wait for 2 minutes. So I'm just going to switch it. I require just 1 or 2 minutes to add camera module. So very simple. So I have this camera module with me. Camera module. This is a jack. Remove this jack and insert it here. Now insert the jack, lock it, and now we place the camera. So I have added the camera. All is connected and now connected. So I connected the camera module. System is on. We'll check here. This thing. Okay, so now system is rebooted. First, we will check. Okay, so desktop I have created this web folder. You can see this image with, and at present there is no content inside. Right? So first, we'll check whether camera is working or not. So we have this ability. Rest still. By still, rest by still, I don't know. First dot GPIO. Okay. Let me check command. Rest by still. I think some English will be the camera working. Thanks. I think we should be connected. Give me 1 or 2 minutes. Hope now it will work. So meanwhile, I will explain my PPT. So these are some commands. Rest is still to get the images. You can specify the time for preview. like 15-second preview is there before capturing an image, and you can specify the width and height of the image. Some segment of the image is also specified. And here continuous images are picked, and can even get the images, that in different formats. And you can get some effects on the image sticker. And this is a command GPIO to just display the image. Okay, so we explain. So now system is connected. Let me check 1 second. Mesh width. So I think this time it is well. So we have another command. This is GPIO. So here you can see that this image is that picked by the camera module which is attached to the Raspberry Pi. And let's say what is the beauty of these different commands? You can embed all these commands that in programming. Okay, so this is the way to get the preview. I'll explain just one more command. Actually, this preview is available in the image, that in the monitor, because this continuous preview is not captured. That on team in VLC viewer. Okay, but in the monitor connected with the Raspberry Pi, you have seen that the preview, which has been recorded before taking the snapshots. So this is all about the image. Now, in the same way, we can capture the video. So this is the way Raspberry bit -o and specify the image video. So video small duration is recorded. Now video I will show you in the camera, because on UGC we can also check whether open it, desktop, image quick. This is the image. So this image is visible to you, right? And this is the video. So this video is also right. So in that way, programmatically we can capture the image, we can capture the video. And now we are just moving ahead with the programming. So suppose if you want to capture something programmatically, this is the way to achieve. You need to just import the class Pi camera from this Pi camera module library, and you need to just take this function slip from this module time and create the object using this class. Just start the preview and just wait for 5 seconds. Means now the preview will be on for 5 seconds. After that, image will be captured with this name in this location. Okay, and then you are going to stop this preview. So this is the way programmatically we can capture the images and the video, that using this camera module. In the same way, if you want to record some video with the help of the programming, So you need to just start the preview, and now your API has been changed. You need to just write camera.start recording and just place the location of the file. So it will record for the 5 seconds, and after that, this recording will be stopped and you will be stopped like this. Okay. And these are some programs. So this is like camera preview test program. So you are just getting the preview for 5 seconds, and then you are just going to stop the preview. So we can test some programs here. And test now. Camera capture test. Okay, so this is the small program. Can make it preview for 5 seconds, and then you will take the snapshot. So I'm just going to run it. And now you can see your desktop. You have this folder, and now this is your folder. It is a name. Let me check. This is what image.jpg. So here, this is the image generated today using some programming, right? And it's like so now just moving with another program, camera image resolution. So this is a way to achieve the different frame rate and resolution. Again, you are capturing some image. So just moving with the camera resolution. And then so for open, here is the load, and you can camera image resolution file to be open. So here you are setting the resolution and doing. So this is like max.jpg, max and resolution image you are achieving. Just run it, and you will see that you have the max.jpg. So you have this max.jpg here, and you can see now picture is captured with the highest resolution. Okay. And the next we have camera time-lapse photography and how it will work. Stop it and just load on the file. And camera multiple images. Multi-image file. So you are capturing multiple images, okay, with different names for like range 1 to 5. After 2 seconds interval, 5 images will be captured. So I'm just going to run it. Okay, so it will take time. So here you can see these images are generated. This is 0, 1, 2, 3, 4. So this is automatic generated by the programming. So here you can see image 0 is there, and image 4 is there. So programmatically, you can just generate a series of images. Right? So the slash photography meaning is that for specific time, that each day you are capturing that images of any location. So in that way, that you can create a good image video of like 365 days of particular. You no need to that just that personally capture the images. Okay. So like this is the beauty of this programming. So there is another way you can animate text in your images, right? So I'm just going to launch another program. I'll just stop it and just load another program. Camera annotate text. Okay. So if you want to write some text in your images, even you are capturing images, but if you want to write some message on your image, you can also do that. So just start your preview and just write down the annotation, text background, foreground, and what is the text of the annotation. And once you capture this image, that this annotation will be also available on the image. So here you can see how it will work.
आई थिंक सर डिस्कनेक्ट हो गए हैं, है ना?
शायद सर।
हाँ जी
Yes,
सर।
sir.
देखते हैं, वेट फॉर 5-10 मिनट्स। हेलो सर, मुझे लगता है आप, हाँ जी, डिस्कनेक्ट हो गए शायद। सर अभी ज्वाइन करने की कोशिश में है और ऑलमोस्ट उनका जो लेक्चर है ना, दैट इज ओवर। तो मान लो कनेक्ट हो जाते हैं तो वेल एंड गुड, अदरवाइज वी विल प्रोसीड फॉर लंच।
ओके सर।
हो गया, ये पंखा चला दे। हाँ सूख जाएगा, पहला ही बटन है शायद। सो नाउ आई थिंक सर जो है ना कनेक्ट नहीं हो पा रहे हैं। सो we may proceed for lunch and again be there at 2. Right, sir?
Okay, sir.
Vijay Singh, sir. Okay?
Okay, sir. Okay, sir. Thank you.
ओके सर
Okay.